will take around about 35-40 minutes, about 40 minutes, and then we aim to leave about 15-20 minutes at the end for questions. So yeah, if you have any questions, please maybe you could keep them to the end. After Christian has given his presentation, and yeah, we're very much hoping we can have a bit of a discussion at the end as well. But throughout the presentation, if you could remain on with your microphones muted, that would be helpful. And yeah, I think those are the main housekeeping things that I need to say. So maybe I'll get started. As many of you may be aware already, Survey Futures is a very major research program and investment in the UK, which is kind of focused on ensuring kind of large-scale surveys in the UK can continue to innovate and adapt to a changing environment. So it's funded by the UK's Economic and Social Research Council, and it's a collaboration between 9 universities in the UK, and it also involves 3 of the survey agencies in the UK, NatSem, Ipsos and Varian, and it has the National Centre for Research Methods and the Office of National Statistics as a partner. So it's a very large kind of programme of work covering many different research strands, and we have a website if you would like to know more about the project as a whole. If you could move on to the next slide. And so yeah, this is a workshop arising out of Research Strand 5, which is focusing on complex measurements in online self-completion surveys. Yeah, so essentially we'll be talking about one of these topics today, which is measuring cognitive function or cognitive assessments. But this work strand also covers industry and occupational coding, consent to data linkage, and event histories and retrospective data collection. But essentially it's focusing on how we optimally collect complex measurements in this of these kinds in an online context. And so yeah, I think the title slide that Christian showed earlier has the kind of co-authors on of the work that we've been doing around this project, which is involving myself and Matt Brown at the Centre for Longitudinal Studies, and Christian and Olga Maslovskaya at University of Southampton. So I think that's all I need to say by way of introduction. And I'm going to hand over to Christian now. Over to you, Christian.
Thank you, Lisa. Good afternoon, everyone. So yes, as Lisa was saying in the introduction, cognitive measures are part of the complex measurements research strand of research of Survey Futures, because cognitive function is a key determinant of health, economic, educational, and social outcomes across the life course, as we all know. And incorporating measures of cognition into large-scale surveys enables researchers to track population trends, detect early signs of decline, and evaluate potential interventions. However, as we will see later in this presentation, administering these measures in online surveys is challenging, as many instruments are designed for in-person administration, and there is strong evidence of mode effects when they are adapted for online self-administration, and we will see how this translates into practical implementations of these kinds of assessments. We recently published an evidence review on cognitive function measurements in online self-completion surveys. We are providing a QR code if you're interested in having a look at it. There's also a link in the slides, and the slides from this workshop will also be made available on the Survey Futures website. Basically, the review focuses on reviewing large-scale surveys that have implemented cognitive measures for different population groups, including the aging population, but also children, young people, and also in general population surveys. We review academic papers, conference presentations, survey technical reports, and other published literature. So although the main focus is on large-scale probability-based surveys, we have also included some experiences maybe in smaller scale surveys, which have also conducted some interesting experiments for measuring cognition in an online setting. So the evidence review describes the issues related to cognitive data collection, and this can include things like, well, first we identify the surveys that have used web-based cognitive ability measures. We describe the cognitive questionnaires and test batteries and many other methods of data collection that have been used. We characterize the data quality challenges associated with collecting this type of data. And we provide some recommendations and best practice guidance for measuring cognitive ability in online self-administered surveys. So at this point, I should mention that we are not providing specific tests or specific batteries saying this is better than this other battery, because we are not in a position to be able to do that, or to evaluate the quality of each test or each method separately. We're just focusing on methods from a survey methodology perspective. So that's one thing to be mindful of. And in this presentation, we, instead of starting from the issues related to cognitive data collection, we will look at several methods of cognitive data collection, and we will try to highlight how they have been used, their pros and cons, and some of the wider considerations for their implementation. So this will allow us to introduce the issues with online data collection of cognitive function. So basically, we will start talking about methods first. And we have used this kind of very basic classification scheme. So on the first group of methods that we review on this document, on the evidence review, we have what we call conventional cognitive tests, which is this typical setting in which participants are asked to complete a cognitive function battery or a set of successive tasks for measuring cognition. And we have distinguished between two main groups of conventional cognitive tests, and this will be important for reasons that will be discussed during the talk. But first, we consider tests that were originally designed for interviewer-led administration. So you need an interviewer to interact with the participant, and these have later been adapted for online self-administration. That's the first group of methods. And then the second group of tests will be those tests that were specifically designed for online self-administration. And there's, of course, some differences between the two from a survey methodology point of view, and we will touch upon those in a minute. But also we found other very interesting methods for measuring cognition in online surveys. Things like online games, mobile devices, apps, wearables, sensors, etc. That second group. And a final research trend that tries to look at cognitive ability measures derived from survey response behavior. So we also treat that as a second kind of main group of methods in our evidence review. We will start with the tests that have been adapted for online self-administration first. The logic of this is that long-running longitudinal surveys have historically collected cognitive data through interviewer-administered modes, so in person and via telephone. And these tests have the advantage of having been widely validated, so they are reliable. They measure what they intend to measure, and they correlate. They have their psychometric properties absolutely validated in the previous literature. They cover domains such as memory, attention and concentration, orientation and language, vocabulary, numeracy, fluid intelligence, etc. And you will find lists of the tests that have been used in the context of probability-based surveys in the evidence review as well. So this is the main advantage of using these kinds of tests, and also that they provide continuity in terms of the time series for having collected this data over time. However, when administering these tests online, these tests that were originally designed for interviewer-led administration, some experiments in several papers seem to show that there are mode effects. We are listing two papers here that report about these mode effects in the context of the Health and Retirement Study, the HRS in the US. So the first paper from 2021 compares data collection in person or telephone with web in 2013, and then returning to in person and telephone in 2014. These are the same participants, of course. And the results seem to show that respondents generally scored higher in web-based assessments compared to interviewer-administered tests. And mode not only influenced the scores in the test themselves, but they also seems to affect psychometric properties or reliability and validity of the tests, which is also concerning. The second paper again compares an in-person round in 2016 with telephone and web in 2018, and in this case respondents again generally scored higher in web-based assessments compared to both telephone and in-person. We have another example with experiments conducted in the Understanding Society Innovation Panel here in the UK with relatively similar results. We are focusing here on the test they did in Wave 7 or on the Innovation Panel, which show that respondents generally scored higher in web-based assessments compared to interviewer-administered tests across all measures, and that the difference persisted even after controlling for socio-demographic variables. Now, at this point, we need to emphasize that mode effects obviously are a problem if you are trying to compare scores obtained via different modes. If you're not interested in the comparison, for example, in historical comparison between tests that were originally conducted in person with online, this is obviously not a concern. So you only need to worry about that in that case. And yeah, these papers and other literature around mode effects in cognitive measures try to find the causes of this, and you can find different arguments for what can be happening in person and in online administration when you try to compare the scores. So obviously in person, interviewers can ensure continued engagement with the survey and provide instructions and clarifications. So this would mean that in-person respondents potentially could have higher scores compared to online. However, it's also argued that the presence of an interviewer may introduce pressure to perform. So respondents can feel like there's a test being taken, and this could have a negative effect in their performance as well. With online self-administration, there's the issue of the possibility of using external aids like calculators, search engines, assistance from others in the household, even AI these days, I suppose, ChatGPT, whatever. And this could also distort scores. However, obviously, detecting actual cheating in these kinds of tests might be difficult. On the other hand, the absence of an interviewer may reduce engagement. This could potentially lead to careless responding. However, the absence of an interviewer, on the other hand, could reduce performance pressure. So there's a lot of factors kind of playing out on these mode effects in these kinds of tests. We have tried to summarize all of the methods with some pros and cons. So basically, the main advantage of using measures that were originally designed and validated for interviewer administration and then adapting there for online self-administration is that it allows you to maintain longitudinal consistency with in-person tests from previous survey waves. So this is a major advantage for long-running longitudinal studies. Self-administration, on the other hand, reduces the potential for interviewer-led biases, which is another great advantage. And the tests also benefit from well-established psychological validity and reliability. So these are three very good arguments for using this. However, we have shown, and we have seen in the papers that we reviewed from the literature, that there's a strong evidence of mode effects. And importantly, some of the papers show that mode effects are more pronounced for respondents with lower cognitive ability, which can be another issue to take into account when looking at these comparisons between these scores. Unsupervised administration can compromise data quality as well. And there's the issue of things like device type, screen size, internet speed, aspects that can influence performance, and this could introduce new biases, and we will be seeing a lot of this when we review the other methods in this talk. So we now move to the second method in this figure, which is measures that were originally designed for self-administration. So more recently, longitudinal surveys have been using cognitive tests specifically designed for remote online self-administration. There are widely validated test batteries available for this, and There are literally dozens of them. When we were building the evidence review, we found out about those. Though 4 that have been used, as far as we know, in large-scale social surveys, or have been more widely used in large-scale social surveys, I should say, are the 4 that we are listing there. So Cognitron, which has been used in the National Survey of Health Development and the REACT study in the UK. Cogstate, which is an Australian one, I think, and has been used in the RAIN study in Australia, also other minor scale applications. Test My Brain, which has been used in the Twins Early Development Study, Next Steps, and the Millennium Cohort Survey, all from the UK. And then there's the UK Biobank study, which is a slightly different case from the other 3, as we will see a bit later on. But we have examples of people using these tests that have been designed for online administration in large-scale surveys. I will start with Cognitron, which is the first on this list. This is an online platform that hosts over 100 optimized cognitive tasks designed to be sensitive, domain-specific, and validated across both general and clinical populations. Or this is what they say, basically. Cognitive domains include things like working memory, language, processing speed, visuospatial, I think it's the way to say it, abilities, and executive function. So I'm highlighting this last 3 because things like processing speed or abilities of locating things in space render particularly well in online environments, or at least when assisted by a screen, so a laptop or a tablet or a mobile phone screen. So these would be particularly difficult to implement in other environments. So this is something that mostly can be done online. In terms of applications of Cognitron, we know that the National Survey of Health and Development in the UK, in 2023, they invited participants with an internet access and an email address to complete cognitive tests using this platform, basically. And participants could access the tasks through a web browser on any smartphone, tablet, or PC and laptop computer. Around 1,700 members of the NSHD cohort, all age 77, were invited to participate. And interestingly, about 89% of those who began the test completed all 13 tasks with a median completion time of 41 minutes. So we thought it was important to highlight this because there have been experiences of getting people of this age to engage in online cognitive testings, which is very encouraging, I suppose. Although concerned participation and completion rates were positively linked to socio-demographic and health-related factors, such as you would probably expect in this case. So there are examples of implementation of these batteries in large-scale surveys. The second battery, which is Cogstate, is a widely used computerized cognitive test battery designed to be repeatable, sensitive, and efficient with a culturally neutral and language-insensitive format. So they highlight this language-insensitive format a lot in their documentation. And it includes domains like working memory, attention, concentration, processing speed, executive function, etc. Again, things that are very doable in an online environment. We know that this was applied in the RAIN study. We didn't find much documentation about it, but we did find some other implementations at a smaller scale, which are interesting because they are some of the few examples we found in terms of comparing performance across devices for online self-administered cognitive tests. So Cogstate was originally developed for using computers, but there are some studies that have supported its validity in other devices, including tablets, iPads, and mobile phones. There's a paper from 2015 which compared performance across devices and found out that participants were faster and more accurate using a keyboard or mouse on a PC compared to a finger touch on an iPad, although people preferred the iPad and believed that they performed better on it. So they did kind of a small qualitative work at the end of this paper. And a more recent research paper found that participants, again, it was confirmed that they were faster on computers compared to smartphones. And while over 85% of participants found text and button size appropriate for smartphones, there was no strong preference for either. So again, people seem to perform better or using a keyboard on a laptop or a PC. However, we have to highlight that issues like fatigue, distraction, and input method challenges, so the challenges derived from completing these assessments online, were noted for all devices. So we have to be mindful of that. The third battery we have is the Test My Brain platform. This is hosted online. The tests, they say, they have been widely validated and they have demonstrated high validity and consistency with tests taken in lab or clinical settings, with domains including things like vocabulary, processing speed, memory, executive function, etc. We have concrete examples of using these tests in the UK context. So we know that the Millennium Cohort Study age 23 and Next Steps age 32 surveys, which are both CLS surveys, and they are both mixed mode surveys, including both online and in-person administration. They use the backward digit span from the Test My Brain. The Millennium Cohort Study age 23 also used this Troop test, although this was not strictly part of Test My Brain, but that's a minor quibble, I suppose. The tests were administered as part of the web survey for online participants, and for in-person participants, the same tests were completed by a self-completion on the interviewer's tablet, with interfaces being identical in both modes. This is an important idea, and we will come back to this when we look at the conclusions and recommendations, because we think this is key when trying to reduce the possibility of mode effects when you include in-person administration in a mixed mode survey. There's also a methodological study by the Center for Longitudinal Studies, in which a convenient sample of 1,800 participants aged 20 to 40 living in England was recruited. Participants were asked to complete 2 surveys, both of which included the backward digit span 2 weeks apart from each other. And participants were allocated to web, video, or in-person modes at both time points, creating 9 mode sequences, and the backwards digit span was completed via self-completion in all modes. Again, what we were saying before, people being allowed to use self-completion even for interviewer-led modes. And although this is not published, early findings seem to show that mode effects are minimal when you take all of these precautions, basically. So that's very encouraging. We also have this study from 2021, which analyzed cognitive test scores from about 60,000 participants. This is not from a particular study, but basically you can this is from volunteers, because Test My Brain allows anyone to register and participate in cognitive tests in exchange for individualized feedback. So basically everyone can do it. I started doing it, but didn't finish it actually. And in this paper, they found that users of mobile devices, particularly those on Android smartphones, which is interesting, performed significantly slower on tests of reaction time than laptop and desktop users, which sort of highlights issues like device latency, which is the time between when you give a command to the computer or to the device and when you get a response from it. And this can vary a lot across devices. But other things like operation system, input type, screen size can also influence results. And so this is something that has to be considered when administering these online tests. Finally, we have the UK Biobank battery. Biobank is a large prospective cohort study which investigates the health of middle-aged and older adults in the UK, with around 500,000 volunteers aged 40 to 69 when they were recruited. This is a non-probabilistic sample, of course. And in this case, I was mentioning that this is slightly different from the other batteries, because cognitive tests here are completed and supervised via fully automated touchscreen interface in a lab setting, so it's not actually completed at home. They have chosen tests from other different batteries, both from the HRS and from the other batteries that we have seen now, but they have some of their own tests as well. We found a paper which found strong concurrent validity and consistency between the UK Biobank cognitive battery and established standard tests of cognitive ability for participants. However, and this is also interesting, there are some variations across tests and domains. So I suppose the recommendation would be to look at the reliability and validity for each test, because there could be strong variation across different batteries. So to summarize, we have a lot of tools for online self-administration and a lot of tests available. And the pros of this method is that it obviously removes potential for interviewer-led biases. They are built on a foundation of well-established validity and reliability. And as we have been seeing, it could help to minimize mode effects as you are using tests that have been originally designed for online administration. In terms of cons, obviously, we have the issue of unsupervised administration, which could potentially compromise data quality. And there's the effect of devices that we were talking about in terms of device type, screen size, internet speed, and other things that can influence performance, introducing potential new biases, which would not be desired for these kinds of surveys. We will briefly move to the other methods, things like online games, mobile devices and apps, server response behavior. We will start with online games, which I thought was a very interesting approach for measuring cognitive ability in surveys. We found basically two types of games. So the first one is specially designed games created to boost engagement. So in this case, the idea would be to for people to just play the game and not necessarily being aware of them being in a cognitive assessment evaluation environment or in a test environment. But there's also some conventional cognitive tests that have been embedded within a gamified environment. So this could also increase engagement by respondents, but it's a bit different from the first one. So an example of the first of the first type of game is Sea Hero Quest, which is a smartphone and tablet-based video game that assesses wayfinding and path integration. So these are two important cognitive domains. The players of this game need to navigate a boat from a starting point to various destinations in a map. We included this in the evidence review because it has been implemented in Wave 16 of Understanding Society's Innovation Panel. And they report that around 47 of the invited participants downloaded and started using the app, with game completion rates varied according to incentives offered, because they embedded this within an incentive experiment, but it went from 47 to 57% of those who started the game, which are encouraging results. The second type of game, we found it has been applied in the TED study. So this is the Twins Early Development Study in the UK. It's called Pathfinder, and this is a gamified assessment that embeds 5 cognitive tests within an engaging storyline. So cognitive tests include things like visual puzzles, matrix reasoning, verbal analogies, vocabulary and missing letters, etc. And it was implemented in a sample of 4,721-year-old twins from TEDs. And interestingly, there is a paper published with the full results of this implementation, and measures derived from Pathfinder demonstrated reliable verbal and non-verbal scores, which correlated substantially with standard cognitive measures collected at earlier stages of TEDs, which is again encouraging results from this game implementation. Now, with online games, we know that, well, if they're fun, they can increase participant engagement and reduce attrition. They can provide a more authentic measure than just static tests by simulating real-world dynamic environments, and as I was saying, reducing this sensation of being in a test and being submitted to an evaluation. And of course, it could generate beyond just game scores, rich process-oriented data that could allow people to characterize the participants' cognitive ability in several other dimensions. In terms of cons, of course, game performance can be influenced by factors that can be confounded with cognitive ability. So things like motivation, familiarity with game mechanics, device type, connectivity, and basically the general aptitude for digital games. So not everyone is a fan of digital games, and this could be an issue when trying to obtain cognitive ability evaluations from these results. Design and implementation, of course, can be costly, and although there are indications that these indicators could be reliable and as a good proxy for cognitive ability, there's not that many studies doing this evaluation yet. So this is possibly work in progress, and maybe in the future we will have more information about how this correlates with other indicators of cognitive ability. We now move to mobile devices and apps. So the idea here is that cognitive measures can be collected from mobile devices, wearables, and apps due to the widespread use of smartphones and these other devices with high storage capacity and connectivity. And this, luckily for us, includes among the aging population, so almost everyone has a phone these days. Smartphone-based cognitive assessments, of course, include mobile versions of existing tests, as we were discussing before, but also there are new tests for mobile devices, which are usually implemented as brief, frequent, and repeated assessments as well. But more interestingly, there's other data types that can be collected via smartphones, sensors, and other devices. These obviously haven't been implemented in large-scale surveys yet. But we have included them anyway because they're interesting and they show a way to what can be done in this aspect. And this includes things like speech analysis apps, so analysis of vocal characteristics that has been used to detect irregularities in human speech and language, which has been linked to cognitive decline. Analysis of physical movement, so things like fine motor skills measurements derived from tapping on a tablet screen have been used to detect irregularities in finger dexterity, which again can be linked to cognitive decline. GPS data, because distance covered has been used to measure cognition, as smaller distances have been associated with cognitive decline. And there's more fancy implementations like activity daily life performance, things like virtual reality environments like virtual supermarkets, automated teller machines, face recognition, apps that simulate pillbox management and that kind of thing, which are collected via sensors and wearables in lab environments. But these are also interesting ways in which you could infer cognitive ability or extract data of cognitive ability from participants without necessarily submitting them to a test environment. So mobile devices and apps can be non-intrusive if you're not basically implementing them in a lab. They require minimal user effort. They can collect large volumes of high-frequency data, and they can increase participant engagement, improving accessibility and reducing or eliminating interviewer effects. However, as we were seeing before, we have the issue of that performance can be influenced by factors that are not necessarily cognitive ability, including contextual and environmental conditions, the physical state of the user, device type, connectivity, etc. There's a risk of attrition that has been shown and missing data due to things like battery consumption, privacy concerns by the participants, and the need to carry the device at all times. So that can reduce participation. And the reliability and validity of these indicators as proxies for cognitive ability are not yet well established. So this, again, work in progress. It looks very interesting, and it looks like a way in which this data could be collected massively alongside social surveys, but it remains to be seen if this can be a feasible way. And finally, we found this very interesting line of work that has been going on lately, which is survey response behavior. Basically, the idea behind this is that survey response is a cognitively complex activity, and thus it provides a means of inferring cognitive ability from respondents. There have been studies, mostly in longitudinal surveys, of two types of indicators, so response quality indicators, including things like item non-response and uncertainty, response styles, response consistency, and survey paradata indicators, including the time from invitation to response, completion time of the survey, errors and corrected behavior, keystrokes, mouse and touch efficiency, etc. And when you follow participants over time, a low performance across these indicators has been linked in some studies to cognitive decline. The work on this is relatively recent, as you can see from the dates of this papers. There are two studies from 2023 and 2024 which find a strong association between low response quality indicators and cognitive decline using data from 4 large and high quality surveys, which are ELSA, HRS, SHARE, and TILDA. There's another paper from 2023 which uses data from the Understanding America survey. They found a weak correlation using 7 years of this data. However, they do find a stronger correlation appearing over lag periods ranging from 1 to at least 6 years. So there's an indication that if you detect some sort of decline in terms of data quality over time, that could give you a first indication of cognitive decline. And the paper from 2024 in the third bullet point seems to confirm this, because they find that a machine learning algorithm based on survey response quality data to predict the incidence of dementia and mortality in a sample of HRS respondents outperforms an algorithm based on age and health-based screening strategies. So this is encouraging, and this is very interesting as well. In terms of the advantages of this method, is non-intrusive as well as cost-effective. It provides an opportunity for a direct observation of a complex real-world cognitive tasks, and it can assess multiple cognitive domains simultaneously. And paradata are often, or can be often, available in existing surveys, which is good. However, response behavior, as we know, can be influenced by many other factors beyond cognitive ability, including motivation, engagement. There's issues of social desirability, survey fatigue, and things like device type, connectivity, and questionnaire design might also have an effect. And also, there are early indications that these could be reliable indicators for cognitive activity, but it has not yet been well established in the literature. So, as a summary of everything we've said so far, conscious of time, we've found several large-scale surveys, predominantly longitudinal, that have successfully implemented self-administered online cognitive tests for respondents of all age groups. Significant mode effects are sometimes found when cognitive assessments are administered using different modes, for example, in-person versus online self-administration. These effects are pronounced where tests originally designed for interview administration are adapted for online use, and they are greater among respondents with lower cognitive functioning. And these innovative measures like games, apps, or survey response behavior are a promising alternative, but further research is still required. We defined 2 key recommendations from our evidence review. So we are recommending that for mixed mode surveys, we have to select tests that have been designed for online self-administration and adapt them for other modes, rather than adapting interviewer-led gold standard measures for self-completion. And we're also recommending, as we were discussing before, that those participating in person in these mixed mode surveys should complete assessment via self-completion. Although even the presence of an interviewer can still have an impact on performance. So in this case, maybe post-interview completion, self-completion could also be offered as an alternative. That's something to explore as well. Other more practical recommendations include choosing tasks with short and simple responses, as they seem to be less sensitive to mode and device effects. Ensure instructions, scripts, language, and time limits are consistent across all modes. Encourage participants to complete the assessments in a quiet space to reduce distraction and improve focus. Remind participants that honest answers are vital and that a perfect score is not expected. This could help reduce the incentive to cheat potentially. And of course, when selecting an online cognitive assessment, there are other things that need to be considered, which could be things like the age group, because assessments must be age appropriate, the scientific validity and reliability of the tests, the practical feasibility of their application. So basically, user-friendly interfaces with clear instructions are essential for achieving high completion rates. Implementation costs, of course, is another big issue, because whether licensing, establishing batteries like Cognitron, Cogstate, or developing new data collection methods can be expensive. User testing, piloting tests with the target population ensures the battery is accessible and functions correctly across various devices. And data confidentiality, participants must be provided with clear information on how the data will be used, stored, and protected. We have suggested further topics for further research, things like causes of mode effects and strategies for mitigation, statistical treatment of time series of cognitive data collected in different modes, the whole world of device effects and the treatment, and the reliability and validity of non-conventional approaches. Of course, experimental research is essential in this case. And the last thing I wanted to say is that a survey practice guide on cognitive assessments for online surveys will be published soon on the Survey Futures website, and for each method it will discuss their advantages, limitations, wider considerations for their implementations, and practical recommendations. I think that's everything I want to say. Thank you very much for your attention, and over to you, Lisa, again.
Great, thank you so much. That was great. Thanks so much, Christian.